So now that we know what classes and objects are, let's start coding a little bit more. We have defined our first class here, for example, foodstuffs. The problem is that this class doesn't do much. It just has this pass placeholder reserved word here. So here I'm just telling Python that I'm going to have a class that's called foodstuff, but that class doesn't have any content. In order to give this class content, I'm going to need a couple more concepts, and they are going to be the concepts of attributes and methods, which are basically just new names for things that we already know how to use. Methods are going to be basically the things that I can do with the objects in my class. So they are going to be functions related to the objects of my class. The things that I can do with Pokemon, or with, not that I can do, things that Pokemon can do. For example, I could have an attack method that Pokemon can do, or defense. Or I could have a method for my haiku players that's called pass the ball, receive, whatever, so on and so forth. Set the ball for a middle blocker. I'm going to have functions that define the behavior of the objects in my class, but I'm not going to call them functions if they belong to the class, if they describe the characteristics of what my objects do. I'm going to call them methods. Okay, and in a second I'm going to be defining some of these methods. One in particular, the init method. Before I do that, in our classes and in our object-oriented programming code, we are also going to have something else called attributes. If methods were related to functions, attributes are related to variables. Attributes are going to be variables that belong to the objects in my class and describe the characteristics that the objects in my class have. For example, let's consider this class foodstuff, and let's give the objects in my class some name. It's going to be a variable, which, because it's inside of a class, I'm going to call an attribute. Functions that I can use with the objects in my class are going to be methods. Variables that belong, that describe the characteristics of the objects in my class, are going to be attributes, object attributes. Okay. Continuing with this example, my foodstuff objects will have a name. They will also have a price. Talking about restaurant food, so I'm going to want to know how much that costs. And I'm going to give them a value that's a tastiness. So I want to know if something is very tasty or not so much. And filling power, because some things are very tasty but not very filling. So depending on what I want to do, if I want to eat something really delicious, I'm going to want to eat something that's tasty, and if I want to have some quick bite and go my way, then I'm probably just going to be fine with something with more filling power, even if it's not as tasty. So with this, I'm going to be considering my foodstuffs with these characteristics, with these attributes. So I have now described a little bit more how the objects in my class are going to be, but only with this I have not yet defined a way to actually make these objects, to make my idea, my class abstract idea, into something real, into something specific. To do that, I'm going to need to define a method, a function with objects in my class called init. This, as you can see, has a very particular name. It has two double underscores before and after its name, and its name is init, which is a reserved word. These double underscore methods are sometimes called magic methods or dunder methods, dunda for short, and they are methods that are used in special ways within Python. Okay. You may have also noticed that this particular method, that's magic because of the doubles underscore, also has this self reserved word here. This means that anytime I call this init method, I'm going to have all of these parameters as usual, and I'm going to be using them here, but I'm also going to have one very special parameter, self, which means the object of my class in which I am using this method. Most class methods will have this parameter, because one difference between methods and functions is that methods are usually called on using one specific object of one class. Okay, that's again a little bit abstract, but let's recap. I'm going to have some attributes related to all of my objects, and every time I call this very special magic init method, I'm also going to be considering one special object that I'm going to be using the method in. Okay, so how would I go about using that? When I use the init method, basically I need to write down the name of my class, and then I don't have to write down the self part, but I need to give Python all of the rest of the arguments for the parameters. So whenever Python encounters the name of a class with round brackets and round parentheses and a list of parameters, Python is going to think, oh, this looks like I'm trying to create an object of a class. The init method is also called the creator method. And Python is going to think, okay, so name of a class with parameters, with arguments for parameters, then that probably means that I need to look for an init method inside of this class. It will come here, name of the class foodstuff. Okay, foodstuff, what is foodstuff? Okay, I do have an init method. Do the parameters match? Yes, they do. Okay, and then it will grab those parameters and those arguments and give them to these parameters. Okay, in this case, what it will do is take this self object, and because this is the init method, this self object is created now. The init method is called the creator method because it's used to create objects of my class, and then it will modify it. First it will create it, and then it will give it attributes. Okay, so each of my objects will have an attribute called name, and an attribute called price, and an attribute called tastiness, and an attribute called feeling power associated to them. In this case, we can see this. For example, I have called this foodstuff method, this foodstuff init method with these parameters: ramen 500 for the price, 7.5 for the tastiness, and 4.5 for the feeling power, because ramen is very tasty but not so filling. I have put all of this inside of an object that's called ramen, and I'm printing it. When I print it, I get main foodstuff object. Okay, so Python is telling me that the variable called ramen contains an object of type foodstuff. And I can even print something specific. So if I want to print the price of a ramen, I can do that by just using this dot notation. So go to the variable ramen, and because I know that this variable is of type foodstuff, and all of those objects of type foodstuffs always have name, price, tastiness, and feeling power, I can print one of them. And that's what I'm doing. I gave it 500 before, and here I'm getting the 500 back. Okay. This is how we have created our first object. We defined the class here, defined the behavior with one method and some attributes here, and here we have instantiated the foodstuff class into one object, which I put into a variable called ramen. I saw before a point class, and I could call my point class with base. Okay, and let's suppose that I had given my point class through attributes x and y, and I could have instanced them with, for example, 5 and 7. I could have the same idea. Okay, so I have my abstract class, my specific objects, and I can instantiate them. In this sense, classes are sometimes referred to as factory types of things because they allow you to create different objects. Okay, I can create more than one, and I would have my abstract class and as many specific objects as I want to have. Okay, as I said before, the classes are abstract, they are ideas, they help me describe how the characteristics and how my class, the idea that I'm working with, the concept that I'm working with behaves, and then when I want to have specific things, I instantiate those classes into specific objects. Let's make our class a little bit more useful, because so far there is not a lot that I can do. A very common thing to do is to not only define the attributes in my class, but also give them some corresponding methods which help me to set or get them. Set them means give each attribute one particular value, and get them means to receive, to be able to read the value that's currently in that attribute. These methods are usually written down as set, underscore, and the name of the parameter, name here, price here, the attribute, name, price, tastiness, and feeling power here, and the get one's the same. Okay, as you can see here, I also have this self reserved word because I need to call all of these always with an object. Okay, you can see here with the function definition, they are very, very simple. Sets are just receive one argument for my parameter and then use that to change one of the attributes. And gets are even simpler, just return one particular attribute, name, price, tastiness, or feeling power. And if I do that, I can now define more objects. This is what I had done before. My ramen object of class foodstuff is defined like this, with ramen as name, 500, 7.5 and 4.5 for its attributes. But now I can define another one, curry. This is again of type foodstuff, and when I do that, I'm calling the init method, and I'm going to give this a name that's kareraisu, which is the Japanese name for curry. Well, not for curry and rice. And then I'm going to give this a price, which is a little bit more expensive. It's still very delicious, and it's a little bit more filling than ramen was for me. And I'm going to print the feeling power here. Okay, I can run that easily. I could, if I wanted to, change my parameters, the arguments I give to my parameters very, very easily. Okay. So far I have defined a class and some methods to work with the class. Very, very frequently defined methods, set and get methods that help me access and express the characteristics as attributes in my objects in my class, and because they are in my class, that defines the behavior of all of the objects in that class, I can define one more method that's very, very frequent too. I have defined the init method and all these setters and getters. Let's define also the string method. See, this is again a magic method because it has the double underscore, so it means that it will be used in some special way. The string method usually is invoked, is called whenever Python would expect to find a string instead of an object. So when Python is looking for a string, for example, in a print statement, and instead it finds an object, it will go and see if that particular class has a string method named like this, double underscore str double underscore, in its definition. And if it does, instead of doing what it did before, just saying doing something generic like this is of this class, okay, I in this memory position, it will do something else, something that I can define. For example, here I'm telling Python, whenever you encounter a place where you're expecting a string and instead find something of type foodstuff, then what you should do is write this down. This foodstuff is called, and then write the name, costs about, and then write the price, yen, has tastiness, and then write the tastiness and filling power and write that too. Okay, and I can just run this, and as you can see now, whenever I print something, I get this message. This foodstuff is called ramen, costs about 500 yen, has tastiness 7.5, and filling power 4.5, and so on and so forth. The same for kariraisu and for this maki sushi type of foodstuff that the foodstuff that I have defined here. Crisitoro salmon 400, very very tasty, extremely tasty, but not so filling again. As you can see, as I'm adding attributes and methods to my class, I'm increasing the things that I can do with my class. Now, with this still very simple class, I can already encapsulate the information about the characteristics that I have found necessary to express attributes, and then create objects that have those characteristics in this particular format and print them in a way that humans can read.